Okay, so I'm going to start with the same example that they used in the video, which is hydrogen with the chlorine. All right, so I've drawn the dot structures here, and again, you could put draw the dot structures many different ways, but I want to show you this as a point of strategy. Okay, the way to do this, which I think is the easiest, is to draw this so that the sticky sides of the atoms are pointed towards each other. Okay, so obviously this guy's got one sticky side, chlorine has one sticky side, all right? But notice the sticky side on hydrogen we just happen to draw with it being on the bottom, and for chlorine it's on the top, okay? So realize that I could have drawn this with the sticky side on the right side of the hydrogen, and I could have drawn the chlorine with the sticky side over here. Okay? Essentially what this does is it makes it so the sticky sides are facing each other, so it's a lot easier to visualize these things coming together to make a bond. Okay? So if this single electron comes together with that, and those atoms decide that they're going to share, here's what you would have. All right? So this pair of electrons represents a bond. All right? One of the electrons in that pair came from the hydrogen, one came from the chlorine, and you would draw it like this. And again, what the video goes over is that anytime you have a bond, the bonding electrons can be represented with a dash like that. Okay? So one way to make sure that you're done is to count electrons and make sure that each have the number of valence electrons that they need to be stable. Okay? If you take a look at chlorine here, okay, it's got 2, 4, 6, and then 8 from this pair. All right, so it's happy. All right, let's look at hydrogen. Hydrogen needs 2. It has the 2 from that bond, so it's also happy. So here's another example. We've got a chlorine, a hydrogen, and an oxygen. Okay, and again, the issue here is you've got to decide which of these guys is the central atom. All right, because there's a couple different orders that you could put atoms together. So the video gave this rule of thumb for saying which one, things that are highly electronegative tend to be on the outside, but there's another way to look at it, all right? If you take a look at these atoms here, just let's say how many sticky sides each one has, all right? This one would have 1, this one has 1, and this one has 2, all right? So think of this like a jigsaw puzzle piece. This chlorine would essentially be a piece like this, all right? It would have only one side that it could possibly make a bond with, all right? This hydrogen right here would essentially be a puzzle that's sort of like this, okay? Again, there's only one side that you can make a connection with here, okay? And it doesn't matter whether it's a male piece or a female fitting piece. All I'm trying to do is to show sticky sides versus non-sticky sides, where a straight edge would be a non-sticky side. Obviously, you can't connect puzzle pieces on the straight side, but either the female type of juncture or the male type, you can make a union with. Okay, so if you had puzzle pieces like this, and you had to say which one of these puzzle pieces is going to be the one in the center, obviously it's going to be this one right here, because you can't have something in the center of a puzzle that's only got one side that it can make a connection with. So that's another way to think about which side is going to be central. So if I was to do this, one way that I go about this is I say, okay, this is the side line here, and this is going to be the field. Okay, and this is what we're going to do. We're just going to bring things down onto the field and try putting them together. So let me bring the oxygen down. So now that he's here, you can't both be on the sideline and be on the field at the same time. So I'm just going to go ahead and erase them from up here. Okay. So where can we make a connection? Okay. Well, both of these guys have one sticky side. Well, here I've got the dot on this side of the hydrogen, but remember I could have shown that with the dot up top. All right. So that right there could make a connection. Right there, okay? And so again, if he's on the field, he's no longer on the sideline, okay? And this chlorine, I'm going to do a little rearrangement so that the sticky side is on this side of it. Okay, and again, these are set up so that these atoms can come together and their sticky sides are going to match up. Okay? And if you want to redraw this, okay, what you're going to do, you replace the bonding electrons with a dash, okay? But anything that is an unshared pair, you draw as unshared pairs on the molecule. So, a couple things about making sure that you're right. I'm going to go ahead and redraw the fragments here. Okay, first of all, you should have the same number of electrons in your finished molecule as you do in your original pieces. All right, so that's 7. You've got 6 and 1. That means a total of 14 electrons. Let's count how many total electrons we have here. 2, 4, 6, 8, 10, 12, 14. All right. Also, we need to make sure that each atom has the number required for it to be stable. Look at chlorine. 2, 4, 6, 8. Look at oxygen. 2, 4, 6, 8. And hydrogen has 2. All right. So everything's happy here. This would be the correct way to do it. Keep in mind when I say correct, there's also different geometries that you could do. I could have also drawn it straight like this, but notice that both ways, oxygen is between the hydrogen and the chlorine.